Hi, welcome back. So today we're going to be looking at how you multiply and divide numbers that are written in scientific notation as a way to help you solve a problem that involves really big or really large or really small numbers. And to start off with, I want to talk about the paperweight problem or the how much does the paperweight problem that you all worked on for today's class. People turned in some really great work around that. Um, what most people had done when you looked at the different numbers you were given, where like a single piece of paper you were told weighed 4.5 times 10 to the negative third power, people did a really nice job of taking a number like that and turning it into standard form, so calling that 0.0045. And then likewise, when people saw that, there were what was it, 5 times 10 to the fifth pieces of paper in a case of paper, people turned that into a standard form number, which was a 5 with 3 zeros. And then also use that 100 number, and you ended up multiplying these things together to get your answer for how much did a case of paper, all the paper in a case of paper weigh. What I want to show you is how you could have solved this with keeping the numbers in scientific notation in a way that actually would have made it a lot easier to solve, and also would mean that you wouldn't actually even need a calculator, which I know you weren't supposed to use on this. I have a hunch lots of you used a calculator to solve this problem. Um, and so one thing I want you to look at is most people realize pretty quickly that if a case of paper had 5 times 10 to the fifth papers in it, and the school ordered 100 cases of paper, that in order to figure out the total amount of paper, you would have to multiply these two numbers together. So if you think about this in scientific notation, what you're actually doing is taking 5 times 10 to the fifth and multiplying it by 10 to the second power, because 100 is 10 to the second power. Well, with what I know, and I know you know about exponent laws, I can multiply 10 to the fifth times 10 to the second just by adding that power, because those have the same base. So really, this becomes the number 5 times 10 to the seventh. And that is how many pieces of paper are in the 100 cases of paper the school ordered. The next piece of information you had was how much a single sheet of paper weighed. And so a single sheet of paper weighed 4.5 times 10 to the third, or 10 to the negative third. And so then also most of you figured out that you need to multiply that weight times the number of sheets that there are total, and you would get the total weight of the paper. So if you think again about what you know about multiplying numbers in scientific notation, if each one of these four things is being multiplied, it doesn't actually matter what order you do the multiplication in. And so I can rearrange this expression to say 4.5 times 5 times 10 to the negative third times 10 to the seventh. And that is a much easier multiplication problem to solve than something that's got a bunch of decimals and big numbers all put together. Because I can multiply 4.5 times 5, and that is equal to 22.5. And I can multiply 10 to the negative third times 10 to the seventh just by adding those powers, and I get times 10 to the fourth power. And this right here is the weight of all the papers. Now, if you want to turn this into standard form, you can, because you all know at this point that if I take 22.5 and I multiply it by 10 4 different times, I'm going to just move that decimal point 4 places and end up with this as my answer. And I know lots of you did a great job and you came up with that answer, but what I want you to focus on right now is how you could have solved this without taking these numbers out of scientific notation. And because that's going to be the focus of today. So today you're going to get a couple of different problems to work through and solve. And what we're going to ask you to do is to not change any numbers into standard form. We want you to keep all numbers in scientific notation. And I want you to think about what you know about exponent rules in order to multiply and divide those numbers. So for instance, if you were trying to multiply something like 3 times 10 to the 6th times 2.2 times 10 to the fourth, and if these were two separate numbers in scientific notation, even though these are in parentheses, it's actually all still multiplication. And so I can rearrange this to be 3 times 2.2 times 10 to the sixth times 10 to the fourth, which really just is as simple as multiplying 3 times 2.2 and getting 6.6, and multiplying 10 to the sixth times 10 to the fourth, which is 10 to the 10th. And that right there is an acceptable answer because that's a number in scientific notation. Or if you want that number in standard form, this just tells you it's 6.6, except this decimal point is moved 10 spaces to the right because we've multiplied by 10 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There should be 9 zeros because the 10th space was moving around that 6. The other thing that you might be looking at doing to solve some of these problems is division. And division, again, if you just think about your exponent rules, dividing big numbers in scientific notation is also relatively simple to do. Let's say I've got the number in scientific notation 4 times 10 to the 8th, which would be a 4 with 8 zeros. And if I want to divide that number by, let's say, 2 times 10 to the 6th, which would be a 2 with 6 zeros after it. I could take those two numbers and turn them into these big long numbers. And then think about how to do that division and how many zeros are left, or pull out a calculator. But if you just think about what you know about exponent rules, the other way I could do this is just say, okay, 4 divided by 2, I know that that's 2. And that's going to be times 10 to the 8th divided by 10 to the 6th. Well, it's division. I'm going to subtract those exponents. It's times 10 to the 2nd, which is the same thing as 200, which would be the answer to this problem. So again, the problems today are going to ask you to solve a couple different problems with either very large or very small numbers, but not turn them into numbers like this. Work with them still in scientific notation. And again, if you have any questions, make sure you post on that discussion board and we'll get back to you on those questions as soon as we possibly can. Have a good day.